Hi viewers, this is another lecture on transportation problem. In today's lecture, we will discuss how to test optimality and what is the process, and also take one example based on this particular phenomena. So what is optimality test? After getting the initial feasible solution of a transportation problem, we test this solution for optimality. That is, we check whether the feasible solution obtained minimize the total transportation cost or not. There we start the optimality test to a basic feasible consisting of m plus n minus 1 allocation in independent position, that is to a non-degenerating basic feasible solution. That is, we have to test optimality if m plus n minus 1 is equals to number of allocations. M means number of row, n means number of column. Then optimality can be tested. And to test this, we have a most popular method, modified distribution method, or in short MODI method. And if m plus n minus 1 is not equals to number of allocations, then this may be the possibility of degeneracy. So to remove this degeneracy, we put delta onto the most smallest element, and this will discuss in the next lecture. In today's lecture, we will discuss this MODI method. So in MODI method, first we have to find matrix for ui and vj. That is, write the element which has entry, then put ui and vj to 0 corresponding to maximum number of element in a row or column, and rest ui and vj can be obtained by Cij is equals to ui plus vj. Cij means cost matrix. That is, first we have to find BFS by the Vogel approximation method, and then calculate this m plus n minus 1 is equals to number of allocation. If it exists, then optimality can be tested, and then we can apply MODI method. Then for this, in the last matrix, we have to write element which has entry, and then put ui and vj to 0 corresponding to maximum number of element, and rest can be found by this particular formula. Next, into the next step, matrix for ui plus vj. In this particular matrix, which element arises, put them dot, and the rest will be find out by this particular formula Cij is equals to ui plus vj, that is adding the corresponding ui and vj. Now find the matrix for empty Cij. So from the matrix find in the Vogel approximation method, we put dot in place of element in BFS with matrix which has entry, and rest element remains as it is, which is the matrix of Cij. Now find the matrix for Dij, which is equals to Cij minus ui plus vj, that is matrix obtained in this particular step and the matrix obtained in particular step. That is, we have to subtract this from this. We get Dij, and if all Dij is greater than equals to 0, then basic feasible solution obtained from Vogel approximation method is also the optimal solution, and if any Dij is less than equals to 0, then optimality can be obtained by making loop with one corner as most negative Dij and another as dot through horizontal and vertical lines. Then put minimum theta is equals to 0 and find revised table and revised optimal solution. This is the problem. Test optimality. For this particular problem, to test optimality, first we have to find BFS, and the most appropriate BFS comes from Vogel approximation method. So first we have to apply Vogel approximation method. So for this, first we have to identify penalty row and penalty column. The difference between lowest and second lowest element is 11 and 14, that is 3. In this particular 12 and 15, that is also 3. In this 16 and 25, which is equals to 9. In this particular 4. In this particular 2, in this particular 4, and in this particular 10. So the maximum penalty is 10. So first we have to fulfill this 15. So first enter 11 on it. 4 is remaining. Move on to the next element, which is 21. 4. What is remaining? 9. So leave these two row and columns. Again find penalty. So 12 and 15, 3. 16 and 25, 9. 15 and 30, 15. 16, 25, 9. 12 and 16, 4. So the maximum penalty is 15. So we have to fulfill this 6 onto this particular entry, because corresponding demand and supply 6 is minimum. So 3 is remaining. Again leave this particular column and make a new matrix. So find penalty for this 2 by 2 matrix, and no need to move further. So the penalty for this is 4, 9, 9 and 4. So penalties are tied because maximum penalty is 9 and which is at 2 places. So we have to select the penalty which has corresponding row demand or supply is maximum. So demand for this particular penalty is 19 and the supply for this penalty is 10. So the maximum demand is 19. So first we have to fulfill this to this particular 16. But the supply is 12 and the demand is 19. So first we have to fulfill this 12 on it. What is remaining? 7. So move on to the 25. Put 7 on it. What is remaining? 3. Now the intersection of these two demand and supply is at 16. So put here. That is this is the complete Vogel approximation method. So now make a combined table. This is the original problem. Here we have to put all the entries in this particular matrix. So 2 entries are already written. Now put these entry M2 P1 6, M2 P1, this is 6, no other entry exists. M2 P2 3, M3 P2 is 7 and M3 P3 is 12. So these are the entries. So BFS are X14 is equals to 11, X21 is equals to 6, X22 is also 3, X24 is equals to 4, X32 is equals to 7, X33 is equals to 12, and total transportation cost is equals to rupees 710. Now we have to test optimality first, whether optimality can be tested or not. So here M is equals to 3 and N is equals to 4. So M plus N minus 1 is equals to 3 plus 4 minus 1, which is equals to 6. And all the allocations is equals to also 6, so number of allocation. So optimality can be tested. So applying Modi method. So the first step is matrix for UI and Vj. So in this method we have to put dot to the elements which has no entry, that is this and rest element remains as it is, that is 11, 21, 16, 15, 25 and 16. Now select the row or column which has maximum number of elements. This row has 1 element, this has 3 elements, this has 2 elements. This has 1, 2, 1, 2. So the maximum element in this is the second row. So put UI is equals to 0 corresponding to this particular row. Now the rest element for this particular Vj, this is Cij. So for this is UI and this is Vj, and Cij can be calculated from UI plus Vj. So this will become 15, same as 16 and 21. And rest for this particular 11, the UI can be find from UI plus Vj, that is this will be minus 10. So for this 25 is the element, that is 16 plus UI is equals to 25, that is 9. And for this 16, this will be 7. Now move on to the next step, matrix for ui plus vj. In this step, we put dot in place of entries in this particular step. That is in the first step. That is at this 11, 21, 16, 15, 25 and 60. And rest element will be calculated from corresponding ui and vj. That is, if we are calculating this, then the corresponding ui is minus 10 and vj is 15. And the Cij is equals to ui plus vj, then this is equals to 5. Same as for this is 6. For this minus 3. For this 7. For this 15 plus 9, 24. And for this particular element 21 plus 9, 30. So in the third step, matrix for empty Cij, we consider this combined table. In this combined table, we have to put dot in place of element which has entry. That is, add this 11, 21, 16, 15, 25 and 16. And the rest element remains as it is. That is 19, 14, 23, 12, 30 and 39. Now in this step, matrix for Dij, which is equals to Cij minus ui plus vj. That is, we have to subtract this matrix from this particular matrix. So dot remains dot and now subtract these elements from these elements. So 19 minus 5, which is equals to 14. 14 minus 6, which is equals to 8. 23 minus 3, which is equals to 26. 12 minus 7, which is equals to 5. 30 minus 24, which is equals to 6. And 39 minus 30, which is equals to 9. So all the entries are positive. That is, since all Dij is greater than equals to 0, so all BFS are also optimal solution. So these solutions are as it is. These are also the optimal solutions. So no need to investigate it further. And this subtraction process defined here is written only for your reference. Need not to write here. You just put 14, 8, 26, 5, 6 and 9 here. Concept where any Dij is less than 0 will be taken into the next lecture. So if you like this lecture, then like and subscribe my channel and also share this channel. Thank you.